Hello everyone, I'm Vedant from Georgia Tech, and I will be presenting our paper titled Semantic Gap in Predicting Mental Wellbeing Through Passive Sensing. This work was only possible thanks to the efforts of my co-authors Victor, Shrija, Steve, and my advisors Gregory, Abowd, and Munmun Choudhury. As technology has permeated through our lives, researchers have found new approaches to explain an individual's mental well-being. By using technology for passive sensing, a user can be observed seamlessly in their natural environment, and these passively sensed data can then be modeled to complement traditional approaches and provide us with more holistic inferences or predictions of mental well-being. So far, we've considered a variety of methods to understand individuals with passive sensing. Some of these methods involve technology that's personally owned, and some involved physical or digital infrastructures, such as Wi-Fi or social media. Regardless of what data are sensed, we still need to model these with some label of mental states. Conventionally, researchers have used surveys to capture those in situ labels for mental states, and the responses to these surveys are what we call the ground truth. In fact, survey-based self-reports are considered a gold standard for indicating an individual's experience. However, several psychologists and computer scientists have argued that the ground truth is merely an interpretation of the underlying experiences. Mental states are quite complex after all. So it begs the question, what are we really modeling? Any mental state can be described at least along two aspects: the physical, which is often a visceral reaction to an experience. Think of your heart pounding during a horror movie. The other aspect is psychosocial. This is considered an evaluation of the experience. A horror movie on afterthought might not be as stressful as an additional work on a deadline day. And from the perspective of ground truth, we're only really getting a report of that psychosocial evaluation, which makes us wonder, what are we willing to report and what are we willing to present ourselves as? And that report is what we're modeling with passive sensing. Therefore, we're not modeling the worker's true state, we're modeling an abstraction. And we believe this limitation is the case of a semantic gap. Highlighting this gap can help us consider ways to reduce it. For this study, we leverage a unique data set of passive sensing to present empirical evidence for this methodological constraint that we're referring to as the semantic gap. By highlighting this constraint, we hope to encourage better approaches to passive sensing. Our dataset is sourced from the Tesserae project, and for this study, we analyzed data from 317 information workers, each of whom had approximately 33 days of labeled data. To identify the presence of the semantic gap, we investigate a key phenomena related to it. Particularly, the semantic gap is reduced when the computational signals that we model are affected by the same factors that can affect the ground truth, even if those might not be affecting the underlying state itself. So let's look at the example of stress, and let's look at self-reports again. Self-reports can be affected by various social aspects, such as self-presentation. Now, if we try to model stress using offline activities, say sleep or walking, those activities are not really sensitive to the same social factors that are affecting self-reports. That is why we hypothesize that instead of those features, if we look at language on social media, that would be a better predictor. And that's simply because language on social media can be a consequence of similar social aspects, such as self-presentation. By contrast, for the same day, we could also model a different kind of ground truth for stress, like objective arousal measured by a wearable. And there we would hypothesize that passive data on sleep or walking would be a better predictor because it's no longer restricted by the semantic gap. The figure here summarizes the analytical approach that we just described, and that is known as the data triangulation method. This enables us to compare different approaches to predict different representations of ground truth. The data in the Tesserae project includes both offline activity and language used online. For offline activities, the features are sourced from a variety of everyday digital technologies such as smartphones, wearables, and Bluetooth beacons. This can help describe a participant in terms of their physical activity, mobility, sleep, but also based on their screen use and work behaviors. On the other hand, online language was acquired by participants' social media use. We look into a variety of different features, including sentiment, psycholinguistic aspects of speech, and open vocabulary. Our paper has other details for the feature engineering and evaluation. I won't be going into too much detail for that, so please feel free to look at the actual article for those. In this presentation, I will be focusing on the key results to support our hypotheses. Remember, in both approaches, be it using offline activity or online language, we are predicting representations of the same underlying experience. So if we look at the self-reports for stress or anxiety as hypothesized, when the predictions are modeled on self-reports, the language is a better predictor. By contrast, if we look at, say, objective arousal, offline activity, which is activity like sleep or walking, those are better predictors. So this shows that there is that methodological constraint and we are able to acknowledge the existence of the semantic gap. But now the real question is, what can we do about it? And what sort of features should we start using? So what we need to do is consider ways to actually capture those social influences of the ground truth. So if you look at self-report, we can now consider a new model. It's still using offline activity, but now it's got features such as co-location. And co-location is considered a form of social interaction itself, and therefore it is more likely to be aligned with the factors that influence the self-reports. Here we find that predictions are greatly improved when we actually include those features. As it's evident from the graph on the right, no matter which modeling algorithms we use, we still see a visible improvement. Note, we also tried including these co-location features to predict objective arousal measures, but the improvements we saw were not as substantial. This study really highlights the importance of ground truth and encourages researchers like us to build these passive sensing frameworks with more careful attention to what we're actually trying to infer. Researchers can consider different types of ground truth depending on what factors they anticipate the ground truth to be sensitive to. Most importantly, it informs us to look at our results in a different way and evaluate them based on the labels we predict and not just what the mental states are. Our findings also aim to guide deployments for such sensing studies. Given our access to big data and multiple sensing streams, it can be tempting to throw a bunch of sensors at any participant pool and sift through the feature space. However, broad sensor deployments raise many concerns. It's not just about resource challenges, but participants' privacy and burden. Instead, depending on what researchers really want to sense and how they label the ground truth, we can now be more parsimonious by only focusing on sensors that semantically align with the ground truth. So that's all we have for this talk. If you have any other questions, please feel free to contact me. The details to contact me are given below. Lastly, all of us are very thankful to the Tertiary Project for enabling the study. And for more details about the paper, I really urge you to go and have a look at it. Thank you so much for listening.